That's great. I'll just start now. Hello, everybody. Hope you're all here. Thanks for coming out. This is going to be the. Hold on. I got to stop this. Madness here. All right. So, welcome, everybody, to the Binary Golf Grand Prix announcement, I guess, review of the results of what happened. So, I'll give it a second, too. A couple people are still coming in here. Um, one second. Just getting all this stuff together. So yeah, the Binary Golf Grand Prix has been a really interesting thing. We had gone and done basically like we had like a meme of what what we wanted to do for I guess like a challenge for people because you get a um, like if you're doing any sort of development and things like that, like you always kind of want to test the limits of stuff. And so what we had pretty much done was Dade had suggested that we or he had asked if anybody could possibly make a binary that would execute the same forwards as it would backwards. And so we were thinking about it. I said that it was possible because you could make a com file or something with one byte that would execute the same forward as it does backwards, but it kind of seems like cheating, I guess, to just get to that limit. So we wanted to kind of expand it a little bit. So I had put out this challenge on my website, and I gave some resources on how to make small binaries. And then I had gone and explained a little bit about what you could possibly do. Like here's like a PE file, and then disassembling some of the header backwards, can yield instructions that could possibly be used for something. Then just discuss kind of like what you could do. And so I had, I put it out, and then I had some stuff come up, so I wanted to give it basically an extra month. So we were originally going to end it like last month, and then we decided to push it an entire month beyond what we had done before, and which was cool because we ended up getting some more entries than I thought we would. I wasn't actually sure if anybody would be able to do this because it's very niche stuff and it's frustrating and there's a lot to consider with it, and so I'm really grateful that a lot of people had wanted to be a part of it. So what we're gonna do here for this stream is go over the binaries that were submitted and kind of compare them for the the overall rules because the rules we basically had said were that it has to be any executable format with any OS, any architecture. So this main one here, a minimum should execute 50% of its bytes. That's like the hardest part of this is trying to get a binary to execute every single byte in it. And so that's kind of the thing that I'm doing the scoring on, and it doesn't have to be a some crazy what's it called, like it doesn't have to go all the way to 100% or something because a lot of them didn't even, or half of them didn't even get to 50%. So I'm kind of just doing the scoring based on that because everybody else had done all of these other parts. So this is kind of like the one differentiating factor between all of them. And so we got all these submissions, we got all the repos and stuff like that set up. So I'll be able to share them. I'm going to do like a summary write up too, so people, if they want to actually review the source code and stuff, they can do it on their own. So I guess let's get right into it. So I had made this BGGP ANSI art here to kind of go over some of the entries. So um, I guess we'll get right into it. Unless somebody has any questions right now. Um, Looks like we're good. Cool, cool. Alrighty, so I'm going to, I guess, start up this one here. Where's VirtualBox? Alright, so this first one here comes from Accelerator. This is a x86 bootloader that was written, same forwards as backwards. And so you see it running here. You can boot it up in VirtualBox or QEMU as a floppy disk or just a regular image. And so this is this is the entry that he had Accelerator had done. So all it does is it displays the ASCII art that says BGGP, and then it has Accelerator's GitHub as well. Um, and so he had done a write up which is really awesome. It's this whole write up on his GitHub. So if you go to the website that is here, where did it go? This one. if you go to this GitHub, you'll be able to see. I'll actually throw it in the chat too because it's awesome. So yeah, on the Twitch chat, there's the link to it. And so yeah, he had kind of gone over the different approaches to take to this because it's a bootloader, it's x86 bootloader, and so there's not really much of a header. There's kind of like a couple of constants that need to be there. Basically the bit pattern of AA55, and then some of the other constants things that you have to consider for it. I guess there's 16-bit here, so you're working at a smaller scale than most of the x86, and you're all in real mode. So there's a lot of like interrupts and other hardware things that are a lot more fun to take care or to take advantage of. He had used just printing directly to the screen in the code here. So the code is really cool. So the code actually starts off. There's I'm sure that this is because of trying to, I guess, do the like measure out where certain bytes would go. But this thing here, this is call clear screen. This is a direct call to a function in here that was calculated. The actual instructions are written as just bytes. They're not even written as anything assembling because who knows? Sometimes assemblers can start to, or compilers even can start to mess up where your offsets are. So that's one of the really key points to all this is being able to guess what the compilers or the assembler is going to do for you, and then try to just enforce that. So this other call is like set cursor here, and this other move si message offset. This is all pre-calculated here. The other things here are, I guess he left them in there, and then it does this jump. So actually, I think this one was cool because the jump had jumped the exact length of where the instruction pointer already is. So it's able to take that offset and then use that as a jump value, which is pretty sweet. And so yeah, it goes and it calls through all these different functions here, and it basically runs through this loop to print the string, which is embedded in the middle of the binary. And so if we look at it at the actual highlights, I highlighted in blue every byte that gets executed. So we start here. These are all the calls, and then the loop is, where's the loop? It's like down here. Where did it go? There we go. Yeah, I think the loop is, where is the loop? I'm like getting lost now here. It's 88B01. 88B01. I can't even find it. Well, it's somewhere in here. But basically, yeah, these are the code sections though that it jumps through. This is the ASCII art that's been inverted. So this is what was ended up printing out, and then there's this other thing that goes backwards. And it's cool because you can see where these code sections that aren't actually executed, these are executed down at the bottom here, through this thing backwards here, right here, so it's executed, and then this other section here isn't executed up here, but it's executed down here. And so it's cool to see the jumps back and forth if you go through it in a debugger, to see the how you went from one function to another, calling back and forth between these two. So really, really cool. And so I will, hold on. I'll reveal. So I have these scored, and I'm going through them in the order of least to most execution ratio. So this is doesn't mean anybody did poorly because everybody did amazing here. But this is just strictly the metric that we can use, I guess, to just kind of sort these. And so if we color this in, we see there's 83 bytes were executed out of 512, which leads to an execution ratio of 16.21. Which is a really good job. Great job to Accelerator. That was a really, really cool one. And so the next one that has the second lowest execution ratio was mine. And so we can go through this real quick. This is mine. I posted it on Twitter a little bit ago. And Accelerator posted his on Twitter as well. And so this palindromic 64-bit F binaries, this is like my write-up about this. It kind of has a bit more explanation about what this whole thing actually was, and so goes through my my ideas of wanting to do print out a palindrome and also use palindrome or use alphanumeric shellcode or bytes to have a a word that can also be executed. So I figured out, I guess, pull up, if I pull up as the original one that I wanted, and then I ended up with this palindrome that I made called, or that says puppy spy, sci p pup, which is pretty cute. And so, yeah, this is because you can only execute bytes within the P through Z range in uppercase, because alphanumeric shellcode for x86 was a bit more robust, but they changed the encodings, and it's a lot harder to use that kind of stuff now. And so I kind of go through all the mirroring and things like that, and how I brute force the jump instructions and things like that. And so to run this one, let's take a look here and grab my terminal here. So, all right. So I have this script, build.shell. So it takes the binary and it compiles it, or it assembles it. It takes the assembly listing, sorry, and assembles it, executes it, and then uses Perl to reverse that into another binary, and then executes that. And so you can see we don't have any binaries here. But if we run build.shell, you see that it executes the original binary. It prints out puppy spy p pup or sci p pup. That is a hex dump of it, and then it reverses it and it executes the same, and the hashes are the same here. So that's awesome. It's working, and I'm pretty stoked about it. But yeah, if you want to read more about this, you can read my write-up, which I'll also post in the chat. And that is this. Awesome. So yeah, so if we want to go by execution ratio, so I had struggled with this. There was a way to get it to be legal, I guess, for the amount of 50% of the bytes executed, but it would require adding like something like 100 nops to both ends of this, which is doable, but it definitely was kind of wonky. So I left it the way that it was. If you wanted to try to do it yourself, you can obviously assemble it. But so yes, I did 90 bytes out of 245, which left my execution ratio at 36.73. So that's pretty nice. So now we get into the last two, which were blowing us both out of the water over here. So this one by Visnut, who is a demo scene person. I'll put his write up in the chat too. This is his write up. Visnut had done a 20 byte Commodore VIC 20 demo basically, and so I can show you what this looks like. So if we go to it is and then we do xvic. So we open this up, and this is the Vice emulator for VIC 20, and this is what it looks like. It loads the binary, and it's actually really, really cool. So what this does is it takes advantage of some instructions that aren't documented, and it also basically so the way that this works is similar to the way that if you're going to do something like, say, Windows or Linux library calls, having some sort of offset that's hard coded, and so there's some hard coded offset of a subroutine called char get or chr get, and it grabs it from like a known address, and so it utilizes like a hard coded address in the VIC 20 to actually execute itself. So it's pretty sweet, and it executes a bunch of stuff. So I'll go over that. Cancel Vice. So if we look at this, the only thing that he wasn't able to do this, so the first address, the address of like, I think it's the same on Commodore 64 too. You have to have the first 2 bytes as an address, and then you can go through the rest of the starts right afterwards. And so this executes everything but those 2 bytes, which leads to a execution ratio of 18 bytes out of 20, which is a clean 90% execution ratio, which is amazing. So great job to Visnut. He's done a lot of really other cool stuff, so I would check it out if I were you, because it's really cool. All right, so the last one, binary. This one's pretty mysterious because this person had sent it to me, and then I had like, I guess, lost track of it, or we had lost track of each other here. So here's his write-up. Um, this person here had found this challenge because they had found my I had mirrored this demo collection called Hardcode, and I put it on GitHub so it was searchable. It's a lot of um, demos from bytes all the way from like 1 byte to like, I guess I think it was like 512 bytes, or I forget how many bytes there actually were. But there's JavaScript demos, there's DOS demos, there's all sorts of different ones. So check that repo out. I forget who actually makes it, who compiled it originally, but there's a lot of really interesting things in there. And so this person has been making demos since like the late 90s as well as Visnut, and they had come up with this really cool binary here. So I'm gonna run this for y'all. Um, so this is DOSBox. This might be hard to see because it's DOS and it's tiny, um, but this is the I had taken this and I had turned it into a a binary because it isn't compiled. You can take these bytes if you want to and just put them into a hex editor or something. Um, but yeah, so this is what bggp.com looks like. And so you can't really see it, but right here, there's a blinking E character with an accent over it. And so this one's really cool too, because similarly to Visnut's demo, this one here does it takes advantage of the known segment that holds the screen buffer. And so there's a hard-coded constant to this 07D0, which is a part of the segment that has it's the 2000th byte, which is the center of this, the 80 by 25 screen buffer here on DOS. And it's really sweet. So this thing, it does a short jump over this ret instruction, which is the same as this ret down here, and then it has the jump instruction is encoded backwards at the end of here. And so what this does is it doesn't do these 3 bytes, but the rest of the bytes it executes. So if we color it in here, we can see the execution ratio is 31 out of 34, which wins by a small margin over Visnut's, and that's 91.17% execution ratio, which is pretty sweet. So yeah, this is the end of the Binary Golf Grand Prix, the first annual one. Thanks to everybody who participated. This is like really cool to think that people actually would come out and do something like this. I'm gonna do a write up to submit to POC or GTFO. Some other people are gonna be submitting some write ups as well, and yeah, we're all super excited for doing another thing like this. And so yeah, if this inspires you or makes you think in any way, some kind of way, definitely reach out to me or anybody else here and talk about this, and might plan something for next year or sooner than that. I don't even know. We have some ideas for what a uh, new binary challenge could be. So I will be putting out a write up. So definitely hit me up on Twitter. You can see my at there at netspooky, and we can talk about this stuff. So thanks everybody again for coming out. I'm going to stop streaming now. Goodbye.